Department of Physics, National Institute of Technology, Raipur, Dr. Manoranjan Kar, Associate Professor, IIT Patna, Professor S.K. Raut, Department of Physics, Birla Institute of Technology, Misra, Dr. Tanmay of Physics, PG College, Cuttack, Dr. An Chakrabarti, a Department of Physics, Gangadhar Mehar University, Sambalpur, Odisha, and other faculty from different institutes, research scholars, and participants from different part country. A very warm welcome to all of you in the inaugural session of this 6-day virtual workshop on advanced characterization tools, fundamentals, and application. This 1 week workshop is jointly organized by Syama Charan Sukla Koliva and C.V. Raman Global University, Bhubaneswar. It is a moment of extreme pleasure to welcome the guests who are present here to attend this workshop. So on behalf of organizing committee, principal, staff, and students, I welcome all the eminent speakers and guests for sharing their knowledge with the participants. And thank you to everyone who made this workshop possible with their opinions and views. Uh, as it as it is our tradition, we start the program with the worship of Ma Saraswati, the goddess of knowledge. In this regard, I would like to invite Kumari Anuradha Sahu, student of BSc second year mathematics of our college, Vandana. So, Anuradha Sahu.
Yes, ma'am.
बेटा स्टार्ट करो सरस्वती वंदना.
Yes, ma'am. Good afternoon, teachers. मैं स्टार्ट कर रही हूँ. हे स्वर की देवी माँ, वाणी में मधुरता दो. हे स्वर की देवी माँ, वाणी में मधुरता दो. मैं गीत सुनाती हूँ, संगीत की शिक्षा दो. हे स्वर की देवी माँ, वाणी में मधुरता दो. सरगम का ज्ञान नहीं, नाले का ठिकाना है. तुम्हें आज सभा में माँ, हमें दर्श दिखाना है. गीतों के समुंदर से एक गीत मुझे दे दो. हे स्वर की देवी माँ, वाणी में मधुरता दो. मैं गीत सुनाती हूँ, संगीत की शिक्षा दो. हे की देवा, वाणी मधुरता दो. सरस्वती मैया की जय. Thank you.
Thank you, Anuradha. Now, for the welcome address, I would like to invite the principal of our institute, Dr. Sabnoor Siddiqui ma'am, to bless us with her few words. So, Siddiqui ma'am, it's over to you.
Thank you, Nidhi ma'am. सभी को नमस्कार. शासकीय श्यामाचरण शुक्ल महाविद्यालय धरसीमा और ग्लोबल यूनिवर्सिटी भुवनेश्वर के संयुक्त तत्वाधान में भौतिक शास्त्र विभाग द्वारा आयोजित इस 6 दिवसीय कार्यशाला वर्चुअल वर्कशॉप ऑन एडवांस कैरेक्टराइजेशन टूल्स फंडामेंटल्स एंड एप्लीकेशंस में उपस्थित सभी विद्वानों और अतिथियों का मैं महाविद्यालय परिवार की ओर से हार्दिक स्वागत और अभिनंदन करती हूँ। आज के हमारे मुख्य अतिथि आदरणीय डॉक्टर आयुष खरे सर, जो कि एसोसिएट प्रोफेसर है डिपार्टमेंट ऑफ फिजिक्स के राष्ट्रीय प्रौद्योगिकी संस्थान रायपुर में, आज हमारे बीच मौजूद हैं। मैं हृदय से उनका धन्यवाद करती हूँ और इस उद्घाटन सत्र में स्वागत करती हूँ। आज हमारे साथ डॉक्टर तन्मय बड़ा पांडा सर उपस्थित हैं, जो कि को कन्वीनर हैं और असिस्टेंट प्रोफेसर हैं डिपार्टमेंट ऑफ फिजिक्स सीवी रमन ग्लोबल यूनिवर्सिटी भुवनेश्वर के। उनका भी मैं हार्दिक स्वागत और अभिनंदन करती हूँ और महाविद्यालय परिवार की ओर से उनका हार्दिक स्वागत करती हूँ कि धन्यवाद देती हूँ कि उन्होंने भौतिक विभाग द्वारा दिए गए एमओयू के तहत इस कार्यशाला के संयुक्त आयोजन में अपनी सहमति प्रदान की। आज हमारे साथ अन्य जो विद्वान जुड़े हैं उन सभी का भी मैं स्वागत करती हूँ। हमारे साथ डॉक्टर सत्यनारायण त्रिपाठी जी हैं, जो कि एसोसिएट प्रोफेसर हैं श्री श्री यूनिवर्सिटी कटक के, उनका भी मैं स्वागत करती हूँ। डॉक्टर कमल पांडे, जो कि असिस्टेंट प्रोफेसर हैं श्री जय नारायण मिश्रा पीजी कॉलेज लखनऊ के, बहुत बहुत स्वागत है सर आपका। मैं डॉक्टर मनोरंजन कर सर, जो कि एसोसिएट प्रोफेसर हैं आईआईटी पटना के, उनका भी हृदय से स्वागत करती हूँ। मैं प्रोफेसर एस के राव सर बीआईटी मेसरा के जो प्रोफेसर हैं, उनका भी हृदय से स्वागत करती हूँ और अभिनंदन करती हूँ। साथ ही हमारे साथ आज डॉक्टर अनंत चक्रवर्ती असिस्टेंट प्रोफेसर भी जुड़े हैं, जो कि डिपार्टमेंट ऑफ फिजिक्स के असिस्टेंट प्रोफेसर हैं गंगाधर मेहर यूनिवर्सिटी संबलपुर उड़ीसा के। आप सभी का मैं हृदय से स्वागत और अभिनंदन करती हूँ। साथ ही साथ आज के इस कार्यक्रम में हमारे साथ विभिन्न विश्वविद्यालयों, महाविद्यालयों, शोध संस्थानों एवं तकनीकी संस्थाओं से जुड़े सभी अतिथि विद्वानों का, प्रतिभागियों का और शोधार्थियों का मैं हृदय से स्वागत करती हूँ और अभिनंदन करती हूँ। साथ ही साथ हमारे महाविद्यालय के जो हमारे अधिकारी कर्मचारी हमारे साथ जुड़े हैं और जिनका प्रत्यक्ष और अप्रत्यक्ष रूप से इस कार्यक्रम में सहयोग है, उन सभी का मैं हृदय से महाविद्यालय परिवार की ओर से स्वागत करती हूँ। इस 6 दिवसीय कार्यशाला में विज्ञान एवं प्रौद्योगिकी के क्षेत्र में हो रहे नित नए शोध और इससे संबंधित विभिन्न उपकरणों एवं उनके अनुप्रयोगों पर चर्चा की जाएगी। वर्तमान समय में विज्ञान और प्रौद्योगिकी की नई खोजें हमारे दैनिक जीवन का महत्वपूर्ण हिस्सा बन चुके हैं, ये आप सभी जानते हैं। साथ ही इन क्षेत्रों में हो रहे नए खोज और अनुसंधान से देश के विकास में एक नई दिशा मिलेगी। आप सभी का ध्यान मैं इस कि विगत सत्र में महाविद्यालय में भौतिकी एवं वनस्पति शास्त्र विषयों में स्नातकोत्तर की कक्षाएं प्रारंभ की गई है। धरसीवा जैसे छोटे शहर में इस तरह की कार्यशाला का आयोजन राष्ट्रीय स्तर की इस प्रकार की का ये आयोजन जो है महाविद्यालय को एक नई पहचान देगा। इस कार्यशाला के आयोजन से छात्र छात्राओं एवं क्षेत्र के शोधार्थियों को राष्ट्रीय स्तर के शोध संस्थानों एवं विश्वविद्यालय के विशेषज्ञ जो हैं उनके ज्ञान का लाभ मिलेगा। इस कार्यशाला से छात्र छात्राओं को शोध के प्रति रुचि जागृत होगी और इससे वे शोध के क्षेत्र में अग्रसर होंगे। इस कार्यशाला के आयोजन के लिए विज्ञान संकाय के सभी प्राध्यापकों को, जो कि इसके प्रभारी हैं, बहुत अधिक हार्दिक धन्यवाद देती हूँ, शुभकामनाएं देती हूँ। इन 6 दिनों में कार्यक्रम से जुड़ने वाले विद्वानों को महाविद्यालय परिवार की ओर से धन्यवाद देती हूँ। आशा करती हूँ कि महाविद्यालय के विभिन्न संकायों द्वारा भी इस तरह के कार्यक्रम का आयोजन होता रहेगा और आप जैसे अतिथि विद्वानों का सहयोग हमारे छात्र छात्राओं को मार्गदर्शन देगा और हमारे महाविद्यालय को हमेशा आपका सहयोग मिलता रहेगा। इसी आशा के साथ मैं बहुत ज्यादा समय आपका न लेते हुए आप सभी का पुनः अभिनंदन करती हूँ और हार्दिक स्वागत करती हूँ। धन्यवाद।
Thank you, Principal Ma'am. Now, I would like to invite our honorable chief guest, Dr. Ayush Khare sir, Associate Professor, Department of Physics, National Institute of Technology, Raipur, to say few words to bless this event. So, Ayush Khare sir, please.
Respected conveners of the workshop, other expert speakers, other faculty members, and my dear participants. A very good afternoon to you all. Before starting, I would like to congratulate and thank the organizers for, first for having me here, and secondly for having courage to organize a workshop actually. So organizing a workshop in online mode is a tough task, I suppose. So congratulations to the team, and second I think that you are I am replacing someone in comparison to whom I am nothing, as Bhargavi knows. So it is a tough responsibility or difficult responsibility to be here for 5 or 10 minutes. So thank you once again. Thank you for that. So since this is a workshop, earlier participant, see, things are not like just I say a few words, you listen few words. It is to be kept in mind always. I do believe that I am for stating something so that that keeps you reminding in future that what you are there, what you are supposed to do, right? So as the title of the workshop suggests, that advanced characterization techniques, right? So I do believe that all the participants are here either in the younger age or in the middle age who are somehow related to or involved in intense research. Either they are beginners in research, or they are in the middle of their research, or they are at the verge of completing their research. Now, I have not said anything like PhD, or they are doing PhD. So PhD is something else, and doing research is though related to that, but is not completely obtaining a PhD, right? So those who are involved in serious research, so for those my comment or suggestion is that first you need to like clarify or to be clear in your object, because as you know that most of the research in the present days lead to what in the formation or fabrication of a device which is to be used later in our daily life. So research starts from zero, and after 5 years or 10 years of hard work of researchers, a product of your use come into your daily life, right? So for that you have to be like some what happens sometimes that since I'm not having much to do, I'm working at a very remote place, or I am not having duties, so my research can be cannot be counted a very high at very high level. So this is not like that. Even at a remote place or a smaller place or less with less facilities, you can do better things. So then what, how can you do better things? So when you don't have anything, you have to go for bigger things or sophisticated instruments at other places, right? So when, how would you know that what others are having at different places? So this is the right platform for you to know that what other having in the surrounding or our neighborhood. For example, in Chhattisgarh, I think Chhattisgarh is the only place or only state I can say that where no CSIR or no no reputed lab is there. But we are not that much unfortunate, but we are fortunate to have Maharashtra, UP, Odisha, and this southern states in our neighborhood. So where we have enough number of good facilities where you can get your work done, right? So characterization, as you know, that material science is something that is dominating, that has been dominating the research for last so many years. So those who are doing some research on materials, so materials are there. Either you, now there are two things. only material characterization, or you prepare the material for making device, or you prepare material and make a device, right? So there are two aspects. One is only preparation of suitable materials for others to make a device, or you are also fabricating a device. So for that, you have to like prepare certain materials, right? So when then validate the formation of that particular material. So out of those XRD, whichever is the possible or whichever is the best, you should go for other studies, not for all the samples, right? And you should go for the samples that you suppose they are critical, or they are more say informative, like that. Then so you start with say 10 samples are good. Some samples are good for like optical characterization, like AFM, transmission electron microscope, TEM, SEM. So many other techniques are there, and then you can go for the electrical characterization in the stage when device is fabricated, right? So this should be the approach. Not only all the samples are to be characterized with, or for all the characterization techniques, but you should be limit yourself for that. Second thing is this, that since you are not belonging to that particular place where you are getting your sample characterized, so maybe you are not allowed to enter the scene or the arena, right? So you have to be like, you have to request only, or you have to be matured enough so that you can request, or the people allow you. Otherwise you will not be knowing what actually has happened to your sample, is the result of what, right? So for that you have to be equip yourself with the theoretical background, like how does XRD work, how does SEM work, how results of AFM are analyzed, in that way. So first, on working on any of the devices, I'm not concerned with like characterization, but whenever you are working on any of the devices, on any of the instruments, then you have to be very much like careful, because these instruments are very costly, right? And even the maintenance of such instruments, if they allow you to work on that and it goes out of order, so that will be like very bad for both the sides, for you and for the host institutes. So you have to be knowing all the details. So for example, if you are not knowing much about the instrument physically, like you are not allowed to work on the instrument, but going through that theoretical background and going through these videos which you can find on the YouTube, you can be a good learner, right? So whenever in future you happen to meet or visit any lab where these instruments are available, you can take advantage of them, right? So this is the way, right? Like if you talk of this region like Bilaspur and Raipur, and some institutes of Durga, like rich in these instruments. But what we have, I just tell you that XRD machine, SEM, right? That we have it in our NIT Raipur and Metallurgical Engineering Department. All the optical characterization you can perform in our physics lab at NIT Raipur. So we are good in that. And even electrical characterization, as Bhargavi has been my previous student past, she knows that like all kinds of dielectric measurement now we can perform at our lab only. So like also you should be visiting the websites, because you cannot visit every place physically. You have to be visiting the websites of the respective institutes for getting further knowledge. Being available made available on the websites of these instruments, these institutes, so you can like call them, you can email them, they will definitely respond if they are serious in letting you perform some experiment in their institute or lab. So in this way you can proceed. So like And the last thing is that I would like to add that don't go for the things that because others are doing. Right? Nature, what is the nature of your sample? What proper characterization is required of your sample, that you have to decide. Don't go for FTIR only because it is available in the lab and others are doing. Right? So how to judge? How to judge? What is the demand of time? Demand of time is demand of any publication house where you are going to submit your results. Right? So PhD cannot be completely or always, but definitely your output in terms of your results is counted by the number of good papers in reputed journals. So then you have to be aware that what are the good journals for you, where you can submit your work. So by going into the details of those papers which you want to follow or which you generally follow, you can know that these are the characterization techniques which are directly related to your samples expertise or in the area where you are dealing the materials. So this is, I think, in this way you should approach so that you save your time, you save your money, because money is involved everywhere. Because when things are rare, you have to pay for that. One sample cost around 500 or 1000. Lesser are the number of instruments, more is the कॉस्ट यू हैव टू पे, राइट. जो ज्यादा इंस्ट्रूमेंट आपको मिल रहे होंगे उनकी कॉस्ट कम लगेगी. जो बड़े इंस्ट्रूमेंट जितने महंगे आए हुए हैं उनका आपको मेंटेनेंस उसके इंस्टीट्यूट को बियर करना है, तो आपको उतने ज्यादा आपको क्या करना पड़ेगा, उसके चार्जेस देना पड़ेंगे. तो आप ऐसे पहुंच जाएंगे रैंडम सैंपल लेके, उनको कोई मतलब नहीं है, दे विल entertain you, they will charge you, and then but you will suffer. So you have to be very cautious while choosing the samples for proper characterization. And also, like, papers or journals never ask you that out of, say, you have prepared 10 samples and why you are just presenting the results of these three, that you have to present the results in such a way so that everything is clear in spite of being unclear. Like samples you had so many, but you are presenting those samples, so like it is not like that you are giving some exact results of ABC and then you are giving results of DEF and then electrical characterization of GHI, like that. So it is not like this. So you have to have a certain set of samples, right? So before going for detailed characterization, you have to be sure that these 5 or 6 samples are of good nature, and out of these 5 or 6, there will be at least 2 or 3 samples which are good in electrical characterization, optical characterization, and above all in the structural characterization. So all the best to you. I will be interacting with you 2 or 3 days later in the last session, I hope. So at that time also I will be discussing these things in detail. Thank you so much.
Thank you so much, sir, to motivate us and for your appreciation. Now next for presenting outline of the workshop, I would like to invite Dr. G. Nag Bhargavi ma'am, the convener of this workshop. G. Nag Bhargavi ma'am, please, it's over to you, ma'am.
Thank you, Dr. Nidhi. Respected Dr. Ayush Khare sir, chief guest of this inaugural session, respected principal madam, eminent speakers from different universities and technical institutes, the co-convener of this event, Dr. Bada Panda, academicians from various colleges, universities, research scholars from different institutes all over the map, my dear colleagues and my dear students. With immense pleasure and heartful regards, I welcome you all to this 6 days virtual workshop on advanced characterization tools, applications, fundamentals and applications. This workshop on advanced characterization techniques actually aims to provide an opportunity to the young researchers, professionals and students from different universities, colleges and research institutes across India to know recent advances in the field of various characterization tools and techniques, and also their applications in various fields, applied fields. During these 6 days, there will be 6 technical sessions. Each day, we will have one session of 1.5 hours. All the fundamental fundamental areas of characterization of material will be considered and discussed here. This includes X-ray diffraction, scanning electron microscopy, impedance spectroscopy, UV visible and IR spectroscopy, photoluminescence, and also thin film deposition. During these 6 days, we are going to interact with eminent speakers and subject experts of various fields from well-known institutes from IIT, Indian Institute of Technology, Patna, Birla Institute of Technology, Mesra, National Institute of Technology, Raipur, University of Lucknow, Gangadhar Mehar University, Sambalpur, and Sri Sri University, Cuttack. I am very happy to announce that in response to our invitation, we have received more than 120 registrations. I mean 120 participants all over the map from the state of Jammu Kashmir to Kerala and Nagaland to Gujarat have registered to participate in this academic event. I wish we all have a great time during these days, and the session will be more and more interactive as well as informative. With these words, I thank you all for participating in this event. Dr. Nidhi, it is over to you.
Thank you, ma'am. Now, to present the theme of the workshop, I would like to invite Dr. Tanmay Badapanda, sir, the co-convener of this workshop. So, Tanmay, sir.
Am I audible?
Yes, sir.
Okay.
But you are not visible. I want to see you.
Tanmay, sir, you are not audible.
Am I audible?
Yes, sir.
Any problem, sir?
Can you hear me now?
Yes, sir. Yes, sir.
I don't know. Okay, I'm sorry. So the principal of this college, Dr. Siddiqui, the chief guest of today's inaugural session, Dr. Khare, all the invited speakers, the staff member of the colleges, and the dear participants. So I welcome you all, being the co-convener of this workshop. Most of the theme of this workshop has already been delivered by Dr. Khare, so he made my life easy, and as well as Bhargavi also pointed out. So this idea comes up from Bhargavi basically, that for the budding researchers, when they start their research, they need to know the basic characterizations which are available and how to make this characterization applicable for their research purpose. So when this initiative comes from Bhargavi, so we thought of that for the recent research, which is mostly we are confining to the material science, where there are some basic characterizations which are essential. As Dr. Khare also rightly pointed out, when we start our research, we have an aim or the motivation that we will end up with a device. So it starts with the material synthesis, characterization based on the performance of the device and the basic property that is required for this device. So taking that into consideration, we thought of to organize this workshop. mostly with the experimental characterization, and we are also confined into material science. So in material science, the basic characterizations which are required is the XRD, the scanning electron microscope. Then the most of these material sciences are working in the photoluminations, thin film, and the electrical characterizations. So for that, we have taken out the most important characterization which can associate or which can pertain to this kind of characterizations or application of this material. So we start with XRD, then we went into the SEM. So here, our main focus is not only describe or discuss how XRD, but rather our motivation or the office to how we, after characterization, what kind of tools we can use so that we'll get the right information about this material. If I put you one example, and Dr. Khare will also support me, that when we do photoluminations, our objective is not to simply see excitation or emission spectra or what the band level of the transition, but that also we can take into describing the order disorder within the material. So it is not only that the normal characterization we do, how we can take out more information from that characterization. So that is the aim or the theme of this workshop. Similarly, when Dr. Raut will discuss regarding the impedance spectroscopy, it is not only dealing with the conductivity or what is the impedance related to or what is the dielectric relation with temperature. This kind of information will lead you in the application of solid oxide fuel cell whenever we go for the storage material or supercapacitor application also. So not only we will deal with the fundamental characterization, but also we will deal with how this characterization will be helpful in application point of view. And Dr. Tripathi will also highlight you from XRD how we basically when we say XRD, we only thought of phase formation structure. But we can also have more number of information by this XRD. If we do Rydberg refinement, we can get the information regarding the bond length, the strain within the system, and mostly the change in the structure with respect to the doping. That also we can able to find information if you do the more insight of these characterizations. So by taking this motivation or the theme, designed this workshop where we are focused with the basic characterizations, and the speaker will correlate this characterization with the application point of view. So I hope the researcher and the participants, they will acquire knowledge about the fundamental of this instrument as well as how to do the characterization, then finally end with what kind of application we can do by doing all this characterization. So I hope all of you will acquire a good amount of knowledge regarding the basic characterizations and their application, which is the basic theme of this workshop. So with this, I again thank all the invited speaker and the chief guest of this today's inaugural session for accepting our invitation, and we're ready for delivering there. Thank you. Thank you all.
Thank you, sir. Thank you so much. कहते हैं saying thank you is more than good manners. It is good spirituality. So at the end of this inaugural session of the workshop, for giving the vote of thanks, I would like to invite the senior professor of our institute, Sri Kausal Kishore Sarma sir, assistant professor and head department of botany. So over to you, Sarma sir.
Thank you, Dr. Nidhi. In this 6-day workshop on characterization tools organized by Department of Physics, 16th to 21st of May. On this occasion, several personalities and the scholars have been time, and I have been asked to deliver, as Dr. Nidhi told, to extend my vote of thanks. So I don't find myself competent enough to thank such distinguished persons. So far, our chief guest, Dr. Ayush Kharre, is concerned. His motivation and inspiration has always led us to organize such events and in our institution. So I extend my regards to Dr. Ayush Kharre sir for his inspiration and providing valuable time in short span. Again, I extend my regards and from NIT. Next person in our list is Professor. Such scholars, because I have seen that two institutions. One is BIT Mesra and other IIT Patna. BIT Patna is BIT Mesra is rich in campus and infrastructure, no doubt, but IIT Patna with meager resources, it was simply engineering college, has a long list of successful alumni. And person Dr. Manoranjan Kar, associate professor, is eminent worker, well known to us, and he has contributed his time, spared his valuable time, because most of teachers and academicians from such premium are very big, and it's very tough for them to spare certain time. Next is Dr. S. and Dr. Tanmay Badapan. Whenever we visit physics department, often Dr. Vardevi, head of the department, who is a coordinator of this program, often talk Dr. Tanmay Badapanda and S.K. Rao from the Mesra. For I don't know, I have from biological stream, but their contribution, we come across his name and his contribution, his guidance, cooperation, and co-sponsoring this event. Next is, I extend my thanks to both of them and request them to continue the session with Department of Physics and my institution for betterment of academic to achieve academic height. Next is Dr. Kamal Pandey from J.N. Mishra PG College, Lucknow, very old, very good college, and perhaps we haven't made in any seminar or such events. So in future also you will give your time. So I request all the participants and eminent scholars invited who have deliver invited lecture to get tied up with our institution and Department of Physics in future. So we can achieve something, create some in the field of research or applied field, especially in tools techniques. Mr. Satyanarayan Tripathi from Cuttack and Mr. Anand Prasad Chakravarti from Sambalpur. I extend my thanks to both of them for their participation. Sir, in new education policy, we know that the education of science is incomplete without the knowledge of tools and techniques. In new curriculum, just we were busy in framing syllabus. I saw that one theory class and 2 practical classes is essential for a teacher per day per class. So 1 theory and 2 practical. It simply indicates that how much emphasis is being given to practical work. And these 3 hours means 1 period. So we have to give more and more time to a development of tools and techniques, and our students should get trained. They get degree, but they don't know how to handle tool and technique. They don't know what is spectroscopy. Even a student of biology don't know what is the contribution of a physicist in X-ray diffraction. We all know that it was Professor Wilkins who, due to the techniques of X-ray crystallography, discovered a structure of DNA. Electron microscopy, without which we cannot do anything in biological or medical sciences. So your lectures will be highly beneficial, not for only Department of Physics, but all the research workers and students of science stream. I again extend my vote of thanks, and I also extend my thanks to all the scholars and participants from all over India. It is due to the inspiration of the chief guest or our guiding force, Dr. Khare and Dr. Tanmay, that has led to such a lot of registration. It is indicative of the success of this workshop. So I again thank all you scholars for giving your valuable times in these events. Thank you very much.
Thank you, Sarma sir. Now all participants, I request you to all please stay on the link. The technical session of this workshop is going to start, and I hand over this session to Dr. G. Nagbhagvi ma'am, convener of this workshop. So now it's over to you, ma'am.
Thank you, Dr. Nidhi. We are going to start the first technical session of this event. And today's our speaker is Dr. Anant Prasad Chakravarti. He is Assistant Professor, Department of Physics, Gangadhar Mehar University, Sambalpur, Odisha. He is going to talk on characterization techniques involved for FRP composite exposed to various stringent exposing environments. Before formally inviting Sir for his talk, I would like to give a brief introduction about Sir. Dr. Chakravarti has got his BSc Honours Physics from Kir Mohan University in 2004. He was awarded Gold Medal of Best Graduate among all the students across the university. He got his MSc in Physics from Ravinshaw Autonomous College, Cuttack, which is affiliated to Utkal University in 2006. He has got Master of Technology in Metallurgical and Materials Engineering from Institute of Technology, Rourkela. He has been awarded with the degree of Doctor of Philosophy in 2015 in the Metallurgical and Materials Engineering Department of NIT Rourkela. Currently, he is working as Assistant Professor in the School of Physics, Gangadhar University, Sambalpur, Odisha, a state government university affiliated to Department of Higher Education, Odisha. He has published 25 research papers in reputed journals and conference proceedings. He is actively engaged with conducting 2 research projects funded by World Bank and Odisha State Higher Education Council, Government of Odisha. He has been awarded with many state and national awards. He has got Nalini Kant Swain Memorial Award for being best performing student in the Department of Physics, Ravinshaw College, Cuttack. He has around 9 years of teaching experience for UG and PG students. His research area belongs to composite materials, polymer composites, glass fiber reinforced polymer composites, environmental sustainability of FRP composites, carbon-based nanopolymer composites, green composites, waste utilization, and photoning, curing of FRP composites. This is the brief introduction of with these words. May I now request Dr. Chakravarti to start his talk. Sir, this session is now handed over to you, Dr. Chakravarti.
Thanking you, sir. Thanking you, madam. Esteemed principal, Dr. Siddiqui, esteemed chief guest, professor, esteemed madam Bhargavi, and Dr. Badapanda from CGU. So it is always a privilege for me when there is a intimation to share our valuable or intellectual information with the society or with students or the scholars. But instantly I got the intimation. I could not believe. Yesterday night, Dr. Panda has put me a call that you have to give a talk. So by any cost, by anyhow. And I accepted this invitation, and directly I given the title. But viewing the theme of this program, I could realize that I could share the characterization tools that have been conducted for my research work from my Master of Technology or PhD tenure to this time. So let us start. Let us share the screen and let us start. May I know that how many time I have?
Yes, sir.
How many times it is allowed?
Sir, it is up to 2, sir.
Okay.
Okay, including question answering.
Okay. Thank you, madam.
Okay.
Thank you. So this is the talk title I have provided, that characterization techniques involved for FRP composite exposed to various stringent atmospheres, various stringent environments. So this is Gangadhar Mehra University, to which I belong to. Now the talk will be will be progressed in this line. That first I will provide some basic introduction to the composite materials on which I am working, and what problems actually perceived and what kind of investigation is carried out generally and in recent scenario for kind of materials. And those investigations are based on which characterization techniques and why those characterizations should be conducted. As Sir already told that not all samples do not come with all the samples that will be carried out for any kind of characterizations. First, we have to understand that this sample will be feasible for the characterizations or not. So that what kind of characterization should be conducted. Then such basic analysis of such characterization with a very limited period, and what kind of works is generally conducted from my side or from other side, that will be taken care of. So first of all, let us understand what is composites. Composite composed of different types of components, and that will be physically or chemically separated by clear-cut interface. Generally, we come across some composites in our day-to-day life, like our bone is also a composite. The ceramic bricks we are using in day-to-day life, that is also a composite. And in composite, the two basic components, matrix, which provide the shape and size to the material, and the reinforcement, which strengthen the material or that provide the stiffness to the material. Those are separated by a clear-cut interface, and this interface is the big major issue of this composite. This must not be failed. So interfacial property has to be accessed in many ways, and such kind of material, these are also superior from conventional class of materials like steel and aluminum by providing excellent corrosion resistance, high high space materials like we can use polymer, we can use metal, we can use ceramic as a matrix. But if we go to reinforcement, those can be of different types, like this may be of fiber form, this may be in particles form, this may be in whisker form. So when this aspect ratio, length to diameter ratio is much more greater than 1, then that can be treated as a fiber or long fiber, so to say. So generally in FRP composite, we use long fiber to provide either anisotropic directional properties or multidirectional properties, depends upon the orientations that we can provide. So now basically in polymer composites we can use the matrix materials like thermosetting that can be permanently cured, or thermoplastic, depends upon our use, or glass fibers, carbon fibers, or some particles can be used as reinforcements. And these polymer matrix composites, they can provide high corrosion resistance and lightweight. So when in this polymer composite, we use fiber like fibers or carbon fibers, so then that property will be strengthened typically in the direction in which we have aligned the fiber. So this can provide high specific strength, excellent durability, and typically such kind of composites can be formulated, can be fabricated in laminated structure, means layer by layer structure. So now these are some practical applications of composites. These are some environments, like if you can see such use, those can be used in marine environment, those can be used in high temperature, or that variation of temperatures, that high to low or low to high, and typically in stress, that where some stress are there, and the environment combination of the severities like moisture, like temperature fluctuations, and some radiative environments are also. So now these are some typical problems perceived in polymer composites while these are in used. So typically we can see these are having low thermal resistance and high coefficient of thermal expansion. So when we can use matrix and reinforcements, so they are having unequal thermal expansion. So during expansion, there will be their coefficient of thermal expansion will be mismatched, and there will be strain misfit. So we have to go for mechanical characterizations. In this case, the mechanical properties is to be studied. Similarly, the polymer, whatever we are using in polymer composites, that should be ultimately cured. So to understand the curing techniques, we have to understand the thermomechanical properties of the polymer or polymer composites after its fabrications. So for this, we have to go for some thermal characterizations like differential scanning, calorimetry. Then in also some mechanical properties like flexural properties, tensile properties, hardness. So all these properties is to be studied. Similarly, such kind of polymer composites are very much prone to moisture degradations due to this phenomenon like plasticization and swelling. And so all these challenges is to be overcome, and research nowadays, so scientists and researchers are involving with this to overcome with these difficulties. So now when these composites are exposed to moisture environments, either maybe immersion in water at high temperature or at room temperature, or that will be exposed to an environment where moisture ambience is there at high temperature, that can lead to several deteriorating factors like plasticization, swelling, hydrolysis. So for these components or composites, those are used in such kind of applications where moisture is a detrimental factor, we have to study their mechanical properties rigorously. Similarly, when these are in marine environments, come across with seawater, so on that case, their corrosion resistance, their integrity has to be studied while in use. So in this case, in seawater, that the glass fiber or some fibers, there will be some leaching of alkoxy oxides for glass fibers typically, and obviously there will be some salt assisted moisture absorption, and up to some extent there will be salt penetrations. So on that way, there will be cumulative effect of that salt assisted moisture absorption or that seawater ingression, and that leaching of the glass fibers, and some combined deteriorating factors will be there. So on that issue, we have to investigate their mechanical degradations, the change in glass transition temperatures, and their interlaminar adhesions. Similarly, so when such the composites typically of glass fiber reinforced polymer, I am saying it as GFRP. So these are can be used in some nuclear reactors, materials in some as a that insulators of superconducting magnets. So on that way, you have to study their effect with respect to the radiations like gamma, neutron, and all those things. Also, when you want to improve the property of the composite materials, first of all, you have to focus to improve the polymer based properties. And naturally, when we want to improve the properties of polymer, then we have to think about its curing. So when curing will be perfect, then the properties of the composite materials associated with that polymer will be perfect. And obviously, this curing is the twofold process, that gelation and vitrifications. I'm not going be in that way, but such kind of curing can be studied through several characterizations. So sometimes whatever the composites we are fabricating in our laboratory or in some autoclave synthesis, those the polymers is not cured perfectly. So we have to go for its curing again. That is known as post-curing strengthening. So in that case, we have to know that how many glass transition temperatures before curing or before fabricating, then after fabrications, after conventional curing, after room temperature curing, then after post curing through several methods. Then we have to correlate that what amount of energy is to be provided to the material such that this can give you the ultimate curing property or ultimate thermomechanical property, and that will be very much useful in your different applications, that composites will be used in different applications. So typically the post-curing strengthening can be conducted through some radiations like the high energetic electromagnetic radiations, and those will be taken care of later on. So those electromagnetic radiations will be different types, like UV, then your gamma, then plasma, so X-ray. All such curing techniques are also there, and for this, with respect to different curing, you have to that observe its that threshold point for thermal decompositions through certain thermal characterization techniques like differential scanning calorimetry, thermogravimetric analysis, then differential thermal analyzer like DTA, and of course the mechanical properties through 3-point bend test, tensile test, and hardness test. So all these is to be carried out, and of course we have to go for certain spectroscopic analysis also due to radiations, that is there any change in bond behavior across the interface, that has to be taken care of. So obviously I have told the typical problems associated with these composites and what kind of investigations required for its improvement, and through that what characterization techniques we want, that generally we have known. So that I have listed. To know the mechanical property for such FRP based composites, we have to go interlaminar test, interlaminar adhesion through 3-point bend test, flexural strength through 3-point bend test, tensile strength through tensile test, fracture toughness, residual stress. Similarly, in the thermal category, there will be the monitoring of glass transition temperature through differential scanning calorimetry, and weight loss behavior through thermal decomposition through thermogravimetric analysis. Similarly, some physical properties that while you are studying that how much extent of salt penetrated during salt exposure or seawater exposure, then you have to go for EDS analysis, that is energy dispersion spectroscopic analysis. Then radiation penetration depth in the composite through hardness measurement or micro hardness measurement. Then delamination resistance through fiber pull-out mechanisms. And in spectroscopic category, you have to go for FTIR to reveal the bonding mechanism across the interface or any organic that the functional groups are creating or annihilating. That has to be studied through this FTIR. Similarly, through XPS, that is X-ray photospectrometry, that can reveal the extent of salt depositions or any kind of material that come across during the use that can be studied. Similarly, fluorescence, photoluminescence studies can be done for this FRP-based composites to know that during the use in seawater or in that normal water use, is there any bacterial fouling, and those bacterial samples through those that seawater or normal water that can be characterized.
Sir, your voice is cracking.
Voice is cracking. Now it is coming. Hello. Hello.
Yes, sir, it is okay from my side.
Okay.
Clear, sir. Your voice is clear, sir.
Clear, sir. Huh?
Okay. Thank you. Thank you. So obviously that kind of photoluminescence or fluorescence that can also give you the insight of that is there any bacteria forming or microorganisms is forming or not, that you have to go, but not anonymously, depending upon some confirmatory characterizations from mechanical and thermal. Then you have to decide whether we have to go for these spectroscopic characterizations or not. Then in microstructural characterizations, we have to understand that what extent of fracture is there or what extent of that mode of failures are there through certain fracture mechanism, and that you can investigate through electron microscopy and up to some extent in optical microscopy also. That high resolving optical microscopy of nowadays 500x or 1000x optical microscopy is now available. So those can be that can be used for those purpose. So now let us understand some basics that at a very concise idea that how we can use this mechanical test tools, that is 3-point bend test. Typically now you can see that typically that now you can see this is one point is to be loaded on the specimens, this is another point, and this is another point. So there are 3 points. So typically these 2 points are fixed, this is fixed and this is fixed, and from this the fixed point 2 and 3, the distance is known as span length, that is known as your span length. So in between that span length, the main at the mid the point which is movable, that will can give you the load, and with that what will happen when you provide the load, the shape of the sample will be like this. So typically at this that surface you are providing the tensile load, and at this point you are providing the compressive load. So that means there is an alternative loading of tensile and compressive. So by that, this is that free body diagram of that 3-point bend test. So with respect to that, what will happen? Let us say these are some layers. These are some layers. So there will be relative motion among the layers. Relative motion. And if that relative motion is resistive with respect to high interfacial where we will keep our samples within the probe dimension, and that probe can maximum accommodate 12 milligram of sample, and that dimension is obviously specified with respect to probe. So now when you will give, let us say this is our sample, that, and this is the that reference sample, some reference sample is there, so it is thermocoupled. So obviously when you will put some temperature, so difference in heat flow, that is known as heat flux, okay, that has to be taken care of. When, let us say, our sample that required heat energy to that change its phase or change its behavior with respect to different temperatures, then in this reference sample that heat will be released. So if here it is absorbed, then in reference it will be released. Then if in our sample, if the heat is released, then in the probe this is absorbed. So with respect to this alternative phenomenon of this reference sample, then the trend of endothermic and exothermic peak are coming, and from that the different thermal analysis like glass transition temperature at fast change in this slope, and crystallization behavior, melting behavior, softening temperatures, and melting temperatures, all these can be understood from this differential scanning calorimetry. And of course, when you are measuring the glass transition temperature, you are finding the temperature at which these are transiting from the glassy to amorphous. So in this way, you can measure the thermal integrity, which is very essential for the composite material to know its surface temperature. Why it is known as surface temperature? Because at this temperature up to these temperatures, you can use in the particular environment. So when it exceeding its surface temperature means, then if the temperature of that environment is exceeding, you cannot use if its glass transition temperature exceeds. So in that way, you can claim that in this environment, these composite materials can be used or not used, or up to what extent it can be used for what durations, that can be also studied. So this generally this test can provide you that required. You have to provide the data like at what temperature range you want to scan, then heating rate at what with respect to time the change in temperature must be provided, then slope change. That means whether you want onset value at the slope or midpoint at the slope, that is also required. Like if the graph is changing like this, so this is your onset value, but the mid value is that, so the slopes will go and they will meet at a certain point, okay, so that is known as midpoint value. So generally depends upon the analysis or that range, you have to take onset or midpoint for different classes of materials. You have to decide for your samples. Generally for my samples, I am taking typically onset values of glass transition temperatures. So now then another thermal characterization is thermogravimetric analysis. Here generally what will happen, we will put the samples in a chamber, the thermal chamber, and some heat is that is provided at a temperature, generally up to very high temperature like 800 or 900 degrees centigrade. Then most of that components in that, they will be burnt out, and some residual materials will be left as that it can be studied that how much materials is left out, and from that those materials, why these are not burnt out, is there any that they are resistive to thermal, or this is associated with any material which is incorporated in the composite materials, or this is related to certain volatilized materials, or these are some plasticizers, or any kind of activities going on, pyrolysis or oxidations or decompositions, that can be understood from this thermogravimetric analysis. And this is a very important that characterizations. You need to do this for FRP composites. And when you want to study the microscopic properties, that how many failures are failures, or the the fibers are well distributed in the polymer or not, you have to go for the electron microscopy. So in electron microscopy, as you know, that electrons are incident on the specimens, and there are different radiations are generated, and typically you can use either backscattered electrons or secondary electrons for morpholysis. So for FRP composite, I am using the secondary electrons, okay, because that from the surface it is coming, and obviously that the information of morphology can be better understood through this secondary electrons. And obviously some other radiations are there, out of which the characteristic X-ray is one of them. And this characteristic X-ray can be used, that what amount, that what extent of elements, or what are the types of elements present in that material, that can be understood for your materials. So typically SCM, that schematic diagram is like this. So that electron is coming from a gauge and is passing through several devices, then it is detected, out of which that in which mode you will work, you have to provide the data through the SCM technicians. That he will ask that whether you will go for secondary mode or backscatter mode or EDS mode. In EDS you have to use X-ray. So depending upon your purpose of characterizations, you have to set your the things, the context, and you have to characterize accordingly. So now EDS, what will happen, that different types of EDS are there. One is your known as your point EDS. Let us say this is the section of the material you can visualize through SCM. So you want to know at this point what amount or what are the elements, at what amount these are present, you want to know. So just focus on this point and just go to the EDS mode and scan it. It will give you some spectra, some X-ray spectra, and from that X-ray spectra it will also give you that the weight percentage of those materials, and you can know it. Similarly, another technique in EDS is known as line EDS. So that means similarly, let us say this is the section of the image you can visualize through SCM, and in this line, let us say what are the elements present, you can also understand. That is known as line EDS. Similarly, the EDS map also up to certain area. Okay, EDS mapping also you can do this. That means at a certain very low area that you can specify at this area what are the elements present, at what amount, and this will provide element wise mapping with respect to the different diagrams it will give, and the locus of points it will provide. From that you can understand the particle distributions or other foreign materials incorporated in the FRP composite, whether they are well dispersed or not. So then another class of characterizations so we are using, that is known as FTIR, Fourier transformation infrared radiations. In this case, what will happen, this is basically interferometer, and from this interferometer, that what will happen, you will get the that signals, and that signal is very less. It is very difficult to visualize or difficult to analyze. So with that, the tool or that machinery or that facility, that equipment, it can give you the Fourier transformation of that signal. As you know that the Fourier transformation of some discrete signal can be a analytic like Gaussian kind of things. So with that, what will happen, you can analyze this will be with respect to the intensity versus different wave numbers. So then you have to go through the literatures at what wave numbers these peaks are coming and why these comings, and then you have to correlate with your study that for your material why these peaks are coming. Is it related to some formation of some organic compounds or some that annihilation of some that compounds that you can relate, and this property can be related to your mechanical and thermal properties for better understanding or better confirmation of these results. Similarly, when you are doing certain materials are deposited on the FRP composite, or some salts are deposited, or it is related to certain coatings on the FRP composites, you have to go for X-ray photospectrometry. And this X-ray photospectrometry, you know that when X-ray with sufficient amount of that trigger the valence band electron to go out, and from that will carries the kinetic energy, and that will take the information about the sample, and from which you can know that the elements are present at what hybridization state or at what orbital state, that can be understood, and then you can analyze that whether your that incorporations at a different that extent it is proper or improper, or that the deposition due to certain environment, due to marine exposure, or due to any classes of exposure that is happened or not happened, that can be understood through this. So now all these characterizations at a glimpse I have already told. Now let us come back to some of my works where I have used those characterization tools, and I have found some properties and I have correlated. So first is that I have fabricated this glass fiber reinforced polymer composite, where polymer, in case of polymer, I am using epoxy thermosetting resin. So after fabricated materials, I've exposed to the hygrothermal aging where 95% relative humidity is there, and in hydrothermal, that is 65 degrees centigrade immersed in distilled water. Okay, all these are the parametric conditions for the environmental severities and that is exposed to. So now I have to, with respect to these, I have to study some mechanical properties through 3-point bend test. Then also I have to go for these thermal properties like glass transition temperature through differential scanning calorimetry and ACM analysis. So then the samples that I have studied with respect to increase in moisture gain, that can reveal the decrease in that interlaminar that is interlaminar shear strength. That interlaminar shear strength is your 0.75 into P by BT. P is your maximum load, and B is your breadth of the sample, and T is the thickness of the sample. So that maximum load can be obtained from the 3-point bend test during the failure. So from the load versus displacement graph, let us say this is your maximum load, that is stress versus strain. So at which the you can use this as a maximum load PB, and the breadth and thickness are already with you. Then you can calculate ILSS. Then you can see the trend why these are decreasing or increasing with respect to increase in moisture gain due to plasticizations and other deteriorating factors. Similarly, you can analyze for stress at rupture and strain at rupture, and obviously for modulus, and from that 3-point bend test, all those data can be rebuilt, and you can utilize to understand their mechanical properties, the core mechanical properties. Okay. Now you can also go for the differential scanning calorimetry. So for my samples exposed to this hygrothermal and hydrothermal, it is scanned from 30 degree to 150 degree centigrade, 150 degree centigrade, and after scanning, so this first the peak what is it is coming for all, you can see this is known as transient state. Transient state means that the time dependent state. So that means first of all it will that absorb certain heat, and after certain time it will provide a constant. So up to that time, so there will be the reduction in heat flow, that is known as your transient state. So after that, what will happen? The graph will progress, and at a certain time you can see the graph will change its slope. That is obviously these are exothermic peaks. These are exothermic peaks, and we have to find the first change in slope, where the slope is changing. Those points indicate the temperatures. Those are known as glass transition temperatures, and then you can plot the glass transition temperatures with respect to the histogram, and with respect to different your severities, that quantity with respect to days or with respect to anything else. Then you can analyze why it is deteriorating and why the things are going on. Similarly, in ACM, what you have to study whether the fibers are long, or is there any fiber breakage is there, or there is fiber pull out is also there, or is there any that kind of that is delaminations of the fibers from the matrix. That can be well understood through this electron microscopy. And with respect to that mechanical property, you can correlate that for this stage, the severities of the failures is this much. So definitely the deteriorations will be this much. You can also correlate with this. So now, when generally after moisture conditioning, when the temperature is put to the environment where that temperature is lower to higher or higher to lower, with respect to that change in temperatures, there will be moisture desorption or moisture absorption. And when it will come to higher to lower, the moisture can be frozen and there will be swelling and material integrity will be lost. So with respect to the combined behavior of this moisture desorption from lower to higher or higher to lower, the cryogenic hardening, so there will be the strain misfit. So you can also go for this work has been conducted, that the material is fabricated and it is exposed to different thermal shock environments from low temperature to high temperature for different durations, and their properties are studied. Hello.
Please continue, sir. Khare sir, please unmute your mic.
Okay.
Mute. Please mute. Sorry. Khare sir, please mute your mic. Yes,
Okay.
sir.
With
Please
respect to
continue.
that, the interlaminar shear strength, the pattern, the zigzag trend, or the extent of damage can be understood with respect to such thermal shocks, and also the glass transition temperature, the trend can be understood with respect to different extent of thermal shocks, either from higher to lower or lower to higher, that can be understood. And similarly, the scanning electron microscope, it can give you the insight of is there any fiber matrix debonding, and if it is debonded, why it is debonded, whether it is due to matrix failure or it is due to the fiber failure, that can be understood rigorously if you go to the high, that means at least 1000x or 500x of magnifications in scanning electron microscope. So now when such kind of materials are exposed to seawater, basically, so what will happen, those in seawater, there are salt assisted degradations and similarly moisture induced degradations. So due to that, the specimens, I have prepared the specimens and immersed in up to 1 year, and I have studied its mechanical properties and the glass transition temperatures and their EDS that analysis to know the depth of penetrations of the dissolved salts. So then I have seen the moisture is gradually increased, and at a certain extent it is again decreasing and then increasing. So generally when it is exposed to moisture, this kind of property generally not happens. That the moisture absorption will be sometimes decreased. So that is a very peculiar kind of phenomenon. So then after 6 months of seawater immersion, I could realize 10% reduction in internal laminar shear strength due to non-equilibrium zigzag trend, and obviously the stress will be in the zigzag trend from SQO to 12 months. It is decreasing like this, okay, in a zigzag pattern, not directly. Similarly, after 8 months, there will be 25% reduction in modulus, and whereas from after 8 to 12 months, the modulus is increased. This is very peculiar. Generally, this is not happen. So it is very peculiar. So then similarly, when we go to glass transition temperature measurement at onset values, we can see that from the SQO glass transition temperature, it is no doubt it is decreasing initially, but gradually it is increasing up to certain extent. So then we have to understand that in what way the salts are penetrating or deposited across the interface or into the material, that we have to understand. So first of all, we have to go for its its EDS analysis, where that 0.4 to 0.7, very less insignificant peaks are there. Then you can confirm that without seawater immersion, that insignificant peaks are there, and this is coming the material which is present in glass fiber typically. Okay, so those are generally, we confirm that these are not due to seawater immersions. But when we go for after immersions, after 2 months of seawater immersions and after 12 months of seawater immersion, we can visualize up to certain depth also the point EDS can show the extent of the salts, like potassium in 1.94, 2.44 like amounts are increasing, and at a certain point the FP peaks are insignificant. So up to that we can, from the scale, we can visualize that what extent of salts are penetrating, and we have mapped that with respect to period of seawater immersion, the salts are penetrated up to vast extent, and then we have plotted with respect to the depth of penetration of the salts with respect to seawater, and these are analyzed typically due to the growth of microorganisms. These are locking some of the salts, and those are used as some nutrients for their bacterial growth and catalytic effects of the salts. So from those EDS mapping, I could realize that calcium is penetrating more than magnesium, then potassium, then sodium. This is the trend of that penetration of the salts. And similarly, when I go for the ACM analysis, I could realize after 12 months, the matrix cracking is there and no such fiber is breaking. Getting? So that means the fiber is stiffened and these are grouped, so that will can give you the insight of or the indication of performing the better mechanical properties or enhanced mechanical properties at 12 months from 8 months. And we can see that from around of 6 months, and that fiber delaminations, fiber breakages are there, but in case of your 12 months, temperature is 72.35 and at 90 days 71.19 for 30 ppt, but for different it is 70.9. So that means percentage in and why it is observed, that can also be understood. Similarly, in the scanning electron microscope, you can also the extent of delaminations, the fiber pull out, whether matrix cracking is also there, or that the long damage free fiber is also there, which is indication of that higher mechanical properties, or some fiber breaking is also there, or fiber breaking in axial directions or in its along its diameter, that can be revealed from scanning electron microscope. So now similarly from FTR spectroscopy, if you go for the scanning from 500 or some 450 wave number to 4000, you can see the peaks, that the observance peak you can see, and at different wave number the peak can be correlated, and whether that that you can see here for red and blue, that is known as your 90 days of 30 ppt seawater and 90 days of 40 ppt, some peaks are visible which is not visible here. That means this can be related to formation of amide or aromatic ketone compound, okay, or carboxylic acids, due to that interactions of those salts with polymeric resin, those peaks are coming. Similarly, with respect to seawater immersion at different concentrations, the carbon-carbon, that stretching, that point is also coming, which is not visible in your HQ sample, and that can be the indications of moisture-induced or moisture absorption, and that can be related with your mechanical property. And now you can see from that 3000 to 3840, that is nearly 3500, that is astrom. So what will happen? The that weight strengthening generally comes present. So for with respect to that 90 days of seawater immersion and with respect to concentration variations, generally gradually the wave stressing is shifting, and that shifting can be understood that extent of moisture ingressions, and that can be correlated the primarily observed the mechanical properties, extent of mechanical properties, and finally you can come with the conclusion that why such kind of deteriorations are coming, that can be understood. So now similarly, so generally you can see that the pipes the made up of FRP composites in seawater or in offshore or that sea, that can be used for transportation of seawater to take it to desalination plants, and generally we desalinate it, and after desalinations those that water can be used as drinking purpose. So when the seawater will be flown in this FRP composite pipe for so many longer durations, then that what extent of damage in dynamic conditions, always the seawater interface is changing, and what happens to its thermomechanical integrity we understood through all these characterization techniques like 3-point bend test, DSC, EDS, and ACM. So typically I have arranged the experimental setup. That pipe I have fabricated through this method through a steel mandrel. Then I have that is the epoxy resin is applied on the fiber. Then after curing, the pipe is it is arranged in experimental setup so that seawater is made to flow in this for longer durations, and those seawater at regular interval can be changed to ensure the dynamic interface of the seawater with respect to this composite pipe. So this is the picture of the composite pipe, and this is the section, and these are the samples I have, that 3-point bending test sample, that is from the from the composite pipe. Now the demoisturization extent, it will reveal that that after 2 months the moisture ingression is lowered down up to 10 months, then from 10 to 12 months that is accelerated. So on that issue, the ILS is also degraded at the maximum degradations we can visualize at 2 months, and then it is increased, then from 8 to 10 months it is remains stagnant. It is really rare to happen. So we have found the cause of this. Then glass sunshine temperature through this differential scanning calorimetry, the thermograms and the onset value of the TG, these are plotted, and generally you could see a gradual increase of TG. Generally with respect to moisture, the TG will decrease, but here TG will increase. Okay, so then we have gone for the Fourier transformation infrared radiations, and we could see that several components that at around of 1645 centimeter inverse and 1720 centimeter inverse for the 6 months and 1 year, some new organic compound it is confirmed, which is not confirmed in that is 2 months. That means this 2 months of seawater treatment is not so sufficient enough to that cause the creation of this organic compound inside it. So when we go for EDS analysis from the surface to, that is this is your surface, to in depth, the certain points, the point EDS being captured, and with respect to that the scale I have measured up to what depth the significant peaks of the EDS it is, and we can visualize the extent of penetration of the salt components. Okay, and in reference to the that is untreated, the EDS of the untreated sample. Okay, so then we have gone for X-ray photospectrometry, and we could realize that at 2 months and at 1 year, what are the extent of atom percentage these are deposited, and why these are deposited. Sodium is deposited, it is much more, and why that calcium it is deposited, that is nearly same. So that means calcium it is penetrating much more. So then we collected that treated seawater, that used seawater after 1 year of flow, and we have allowed for cell culture, and that cell culture that in an agar medium it is generally carried out. We have to use some seawater, and we have to mix it in agar medium, LB agar. Okay, this is generally that trigger the acceleration of the bacterial growth. Then after that you can see some bacterial that formation through this indications through this picture. Okay, so then these collected fungus, these bacterial samples, these are collected, and the two samples are prepared, that is in presence of the different salts like calcium, magnesium, sodium, and potassium, and in presence of agar, and in presence of trice buffer solution. So in presence of LB means LB agar means it will just enhance the bacterial formation, and in presence of trice buffer solution it will just kill all the bacteria. It will just kill. Okay, so that means we can see. Then we have fluorescence microscope. Generally, the fluorescence microscope, the typical the transitions of those spectra, and it will give you the mapping where the fluorescence absorbance will be there. So this will give you the mapping. That means these that bright images, that indications of the presence of the bacteria. So in presence of LB agar, the sodium percentage, the sodium extent you can buy much more compared to potassium, magnesium, and calcium. Similarly, when this come to control specimen in presence of trice buffer solution, like you are using kill the bacteria, then only also you can see some fluorescence with respect to sodium, and that very less in potassium, and no doubt it is almost zero in calcium. These are the patches due to those the polymer or those trace elements in the calcium, but this is not due to bacteria. So that means it is proved that sodium is the nutriting agent for the bacteria that can be held. So the bacteria samples, these are just absorbing those salts, and these are deposited across the interface in a manner so that the moisture induced is prohibited after around of 6 to 8 months, for which the mechanical being stagnant or not being deteriorated up to certain extent. So if this will be the case, then such kind of material can be used for more than 40 or 50 years, okay, such that without any damage or without any kind of indication of catastrophic failure. This is, you can see at 12 months, the salt assisted the fiber agglomerations are there. That means fiber bunching is there. And as you know, that bunch of fibers can give you much more stiffness. So that means that the property, all the with respect to different characterization techniques, this can be correlated, and the concluding remarks and for your integrity of the material can be understood and can be claimed. So now, as already I have the properties of the polymer composites can be improved by irradiating through certain electromagnetic radiations. When high energy electromagnetic radiations will penetrate to the material, then what will happen? There will be radical migrations. Radicals are generally the small the ligands inside the polymers, okay, that will migrate generally when they will allow for cross linking. When more the radical migrations, they will meet with that many numbers of radicals, more number of radicals, the cross linking will be much more. So hence there will be obviously what will happen, the cross link, the hardening of the composite will be much more. So keeping this in mind, I have studied that with respect to deep radiations what happened. Also I have did for gamma rays. Then I know it is my focus to study that what will happen to plasma, because plasma comes from the near infrared and up to some extent of ultraviolet, and that some visible is range is also there. So generally the mixing radiations of this plasma, it is very much helpful to cause the curing or that electromagnetic post curing in the polymer composite. These are some typical electromagnetic radiations to which the materials, the FRP composites or the polymer can be exposed, and you can get your curing strength. So now these are some literature, some pertinent literatures. Now I have did for gamma curing, that photonic based obviously, and its range is obviously 30 Hz to 100 Hz. So typically what will happen, I just these samples, the FRP composite samples, these are exposed to 60 kilogray of gamma and 10.5 megagray of gamma. So now you can see that with respect to the megagray, that means when the radiation dose is higher, the strength enhancement is higher. So and when the radiation dose is lower, that strength enhancement is used. That means the lower intensity of gamma radiations, these generally do not cause the radical migrations, and rather they will obstruct that small amount of energy that can obstruct the radical migrations, by which the residual stress generation is much more, hence there will be the decrease in mechanical properties is much more. So similarly, those that the properties with respect to the last transition temperatures can be understood with respect to exposure to lower intensity dose and higher intensity dose to differential scanning calorimetry, that can be understood. Similarly, when you expose such irradiated material to that to 800 degrees centigrade thermogravimetric analysis, you can see that after different doses, the different weight loss behavior is there. Okay, different weight loss. With respect to different weight loss, you can calculate this Y, that is WT minus W infinitive divided by W0 minus W infinitive. WT is the weight at any instant of time, and W0 is the maximum weight, and W infinitive after the loss at final temperature. So that you can use it, and from that you can use it in this Brodus integral method, and that from that the activation energy of the thermal decomposition you can calculate, and activation energy is found to be more or less it is changing, and at 0.5 megagray, that is the lower intensity of high megagray, that means higher scale of that dose of gamma, the property is enhanced. So that is confirmed through the FTIR, that is Fourier transformed infrared radiations, which generally that at this bond at this wave number, the oligomers, that is small molecular complex of that organic compounds are forming, by which they require high energy to bond out during thermogravimetric analysis, for which they can show the weight loss behavior, or that is very less weight loss behavior compared to other. So now the that is scanning electron microscope, typically this we have conducted in FE. You can know that SEM is of two types. One is your thermionic emission types, one is your field emission types. In thermionic emission type, electron gun is there and there is a source that will come. So, but in field emission, you have to change field, that is also associated with certain source, but this is very energetic. So very clarity image you can get through FESM. If you want to know the details of the morphology, so my personal suggestion, you have to go for FESM. And no doubt SEM is helpful, but FESM is that can help you to a very great extent. So now, so that you can know that fiber matrix dipping, that fiber fracture, this picture that you cannot get through general thermionic type of emissions. Okay, similarly the fiber pull out all these potholes, and that is very clarity image you can get, and you can realize that why such kind of things are happening, and delaminations is happening, and you can correlate, and generally you can conclude. Now the last context of this talk is confined to your plasma curing. As you know that plasma, okay, that is can improve that polymer related property, fiber related properties. Generally it can be conducted at low temperature. Plasma is preferred. Why it is low temperature? Let me to explain you in the forthcoming slides. And this is very useful, because at a very limited period, when you expose to plasma, the curing is that extent of curing you can get, and that is not possible through UV, or not possible through that is gamma. Okay, so with respect to that it can trigger the radical migrations, and in the plasma, as you know that there are charge particles are there, the charge particles, and your neutral atoms are also there. Okay, and obviously the ions are also there. Okay, so all these, when you will provide in a chamber, will provide a potential difference, that is, let us say let us say that EV amount of energy, okay, that is, it is related to KT, and that T want to maintain to be room temperature, let us say room temperature. So for this, the T must be your, that is your EV by K, and this K is your Boltzmann constant, remain constant. So E is your electronic charge. So then what amount of voltage should provide so that the LV plasma will be created at the room temperature. So that you can set, that you can, that power level, all those things can be maintained. Okay. So and this is very beautiful and very easy to do in plasma. So definitely in plasma you have to use different gas like argon, nitrogen, air. Okay. So all these plasma can be used, and in that plasma, those charged particle, neutral atoms and ions, they will come together with respect to this high voltage supplied and they cumulatively behave, okay, like a wave packet, okay, and they will nearer beyond the mean free path, which is known as the bar length, okay, by which the illuminations being created, radiations is created, which we generally say it is plasma, okay, and that plasma when it will enter or it will hit the sample, it can penetrate up to certain depth, and it can cause the improvement in properties, which is known as surface modifications, okay, and or beyond surface modifications up to certain depth, okay, that depth can be measured, okay, through the measuring of mechanical properties at the cross section of the plasma treated composites. So now these are some typical benefits of plasma curings, okay. Generally a cold plasma is used through DBD, that is dielectric barrier discharge, atmospheric pressure plasma torch, DC glow discharge. All these are used, and we can set from our side the power levels and the types of gas so that the optimum curing can be obtained. And these are some works conducted on plasma irradiations of these composites. And when it will plasma, that in the plasma, when we that material, then what will happen? We can see for my material, and that is the glass, that is the ILSS is gradually increased. And for 6 layers, that if there are 6 layers, the ILSS is 13%. That means plasma penetration is much more. Similarly, for 12 layers, as it is thickness is much more, so penetration is decreased. So this is 6.98%. Similarly, for 18 layers, that is 6.45%. That means for 12 layers, it is best performing, or 12 to 14 layers, it is best performing for the plasma. So now, keeping this in mind, again I have this work that expose this kind of materials to the plasma with respect to these parameters, that is voltage, then your pressure, working pressure, then power level is 30 watt I have mentioned. So with respect to that, what will happen when I gone for thermogravimetric analysis, I have seen there are different weight loss behavior is there, and with respect to those weight loss behavior, that after 25 minutes the minimum weight loss I can see. So that is due to that plasma treatment, some small molecular complex is forming, and those are taking part in cross-linking process of the epoxy polymer, and that is helpful for the curing of the material, and that is understood from this thermogravimetric analysis. Similarly, from the scanning electron microscope of the plasma treated samples, you can realize that the crashed surface is there, and cracking is very rarely visible, and long damage free fibers are also there. So that means this is the indication of that improvement in properties with respect to plasma treatment. Similarly, that when you add some nanofillers like graphene oxides or carbon nanotubes, typically in this work I have introduced graphene oxides at 0.5 weight percentage, then we could realize that this is the characterization of the XRD, that for the Geo, and this is the characterization of the Roman. I think some talks are there for XRD or Roman, but generally I can tell you that, as you know that from solid state physics, that we have from the reciprocal lattice theory. So when the characteristic X-ray will diffract from the material, okay, so typically of n equal to 1, then what will happen? The X-ray diffraction you can obtain a different, like this. This is the, that is your planes, and this is the X-ray diffractions. And as you know that for the 2d sine theta equal to lambda, n equal to 1 generally we take for first order. So from that d is the interlaminar spacing of the that crystals, and from that d can give you the lattice parameters HKL. So from that you can understood the different crystallographic structures through this XRD, X-ray diffractions, like at different 2 theta angle, as you know that this is this is the 2 theta. So generally with respect to 2 theta you have to plot with respect to intensity, and when you plot you have to take this intensity as arbitrary, because intensity can be vary with respect to machine, but the peak position is specified. So with respect to that you can see different peaks are coming, okay, and you have to analyze with respect to different softwares, okay, that is different softwares like the Rietveld analysis, as Marpanda sir has already told. Through that, okay, you have to go for the published XRD files through JCPDS, the journals are there. Then you can confirm that whatever the material you are fabricating, whether the material it is existed or you have that fabricated any new kind of materials, that also you can visualize it. So generally for your graphene oxide, you can see at 10 degree 1001 that index will come, and at 40 degree one peak is coming, and all these are some impurity peaks. Okay. Similarly, in Raman spectroscopy, as you know that Raman spectroscopy, it is associated with vibrational spectra. So that when you will keep the sample in the Raman spectroscopy, so you can obtain some vibrational spectra in different bands, and those bands like from that the D band and G band are very crucial for these graphene carbon based materials, typically in graphene oxides or reduced graphene oxides, or in graphene as well. So generally in Geo, this must come that the intensity of the D band to intensity of G band, generally it must come in 1, but for my sake it is the laboratory based synthesis, which is 0.72. Then these graphene oxides are used in my material to fabricate this type of composite, that is without graphene oxides and with graphene oxides, and these are exposed to plasma treatment, and the mechanical, thermal and microstructural properties are investigated, and generally you can see that the interlaminar shear strength gradually it is high, it is generally higher with respect to addition of graphene oxide, but at plasma treatment at 25 minutes that interlaminar shear strength it is increased up to 43%. Similarly, the differential scanning calorimetry, it can reveal the glass sunshine temperature increase up to 4.22% with presence of graphene oxide at 25 minutes of plasma treatment. So all these properties that can be visualized, that the confirmatory things can be visualized with respect to different dispersed nanoparticles. Like also one can also do for carbon nanotubes, one can also do for titanium oxides, zirconia, all these things can be conducted, and then you can realize that the addition of these fillers, it is helpful or not. Then again the cause of post curing through plasma treatment, again it is helpful or not. Then you can decide that at what extent of you have to add, and what extent of that curing environment or through in such that the details of the composite materials can be said before using in any kind of applications in marine body or in aerospace, or typically when the risk factor is associated, because as you know that the catastrophic damage in aerospace is a great threat for us. So before using such kind of materials in those applications, madam.
So participants, if anybody interested in asking question to sir, please. It's a time we can ask some questions.
Generally, it is related to applied physics. So the students, because characterization tools are generally, it is common to physics, but the applications are related to mechanical, civil, and applied physics. So the students, it is very interesting topic. Let us see what are the students are asking.
There can be thousands of questions as far as beginners or people involved in this field are concerned, but this is the drawback of this online event, an online event, because most of the students are not like, but you have presented everything wonderfully. I must say, congratulations to you. It was a really nice presentation. Somehow, at some time, like my son got into the picture and like unmuted me. But otherwise, like sorry for that. But it was really a good one, because
Thank you.
it was on the line that the organizer are wanting to have. In addition to like hands-on training is not there, but to like by seeing something visually, they can understand much. But students should be deeply involved and must ask something like question. But I have a simple question, like whenever we get the same image of say some interface, right? 2 or 3 layers are there. Then generally what same we have here, they say that sir, it is not possible, or we are not able to get the exact interface picture. So we have Zeiss product here. Something Evo 18, what they say.
Supernova, that FESM, in that,
No,
through that can be
SEM only. Okay. What you are saying that
FESM.
supernova FECM can give that.
FESM, you can visualize the interface, and through that the EDS, if you take the EDS, and so you have to increase the energy also, secondary electron intensity, then the EDS mapping is very easy, and you can visualize at the interface what are the material mixing, the distribution, at what extent that can be understood.
Because in thin film depositions, when layers over layer are there, then that is a requirement. So in that way we are.
In thin film. So this is my layer-based structure. It can be correlated to thin film-based or multi-layer thin film things. It can be understood.
Right. Thank you so much. Nice presentation, really.
Thank you, sir. Thank you, sir.
So, sir, if there are no questions, so I think I must thank the speaker, Dr. Anand Prasad. Thank you so much, sir. And I'm on behalf of Tanmay sir and me, actually, we are very thankful because you have accepted our request in a very short time. Actually, yesterday night after 7, Bajpayee sir has called me because he was in Jhansi and he could not reach. And he said, I'm extremely sorry, there is some urgent situation is there and I can't reach. And that time I approached Tanmay sir and he said, no problem. I have some wonderful people and experts in different fields. I will arrange. And thank you so much, sir. You have accepted our request in a very short time and it was very wonderful talk. And I think all the participants have definitely get benefited of your talk. So thank you so much on behalf of organizing team.
Thanking you, madam.
And a small announcement to the participants. Tomorrow we have another interesting talk by Dr. Kamal Pandey. He will be discussing the photoluminescence, fundamentals and applications. So please join on time. The program will start sharply at 12. So please join and get the benefit of knowing photoluminescence and its application.
Madam,
So
please, I may request you may please forward the link for that also. If the link is common.
Yes. Same link is there, sir.
I also attend.
My
But I have
pleasure.
to learn more about, because I may be expert in my field, because I have to learn in others also. So,
Sir Kamal Pandey sir will be there, sir. He's from Lucknow, University of Lucknow, and he has an instrument, and probably he will show that also.
okay, madam.
Okay, sir.
Thank you.
Okay,
Thank you,
so
madam.
thank you, sir. Khare, sir,
Thank you, sir.
shall we leave the section now?
Right.
Okay, thank you all the participants. Tomorrow we'll meet again.